Okay, question 14 is a parametric equations question. We've been given the equations parametrically, and this is a Cartesian equation. So we're looking for the Cartesian equation of the curve. It's a slightly tricky one because we've got a sine t and a cos 2t. If we just had a sine t and a cos t, we'd be looking to use sine squared t plus cos squared t is equal to 1 at some point. But we don't have that here. We've got this cos 2t, so we need to think about what cos 2t is equal to. And that's our double angle formula. We're probably going to want to link it to sine. So the cos 2t formula that we're going to want to use is 1 minus 2 sine squared t. If we can somehow bring that in, then that's going to allow us to eliminate cos 2t. So next job is let's make 2 sine t, because we can, from here we can say that 2 sine t, well no, let's just oh right, let's make okay, we're going to make sine t the subject of this one, which will be x minus 3 over 2, and then we're going to work out what sine squared t is. So that's going to be the square of this, so x minus 3 over 2, so x minus 3 squared over 4. That means that we can write here, when we see this cos 2t, we can write 1 minus 2 lots of this. So 1 minus 2 lots of x minus 3 squared over 4. So that's what we're going to substitute in here. The reason I've done it this way around is because y is the subject here. So we want to keep y the subject. So because 1 minus 2 sine squared t is equal to cos 2t, but sine squared t is equal to this, we can say for this particular equation that cos 2t is equal to 1 minus 2 lots of sine squared t, which we're writing as x minus 3 squared over 4. Hope that makes sense. So what we can then do is bring in this y equation, and we can write down that y is equal to 4 plus 2 lots of cos 2t. But 2 lots of cos 2t is 2 lots of this. So 2 lots of 1 minus, I'm going to cancel this 2 over 4 down to a 2, x minus 3 all squared over 2. And then it's a case of rearranging. So that's y equals 4 plus 2 minus, the 2's are going to cancel, x minus 3 squared, which is 6 minus x minus 3 squared, which is what we were looking for from the question that they gave us. B part 1 and then wants us to sketch this curve. So this is a transformed quadratic. It's a negative quadratic that's been shifted right 3 and up 6. So if we start off by drawing a sketch of that, we're going to get something like this. However, where that point is going to be the vertex, that's going to be 3, 6. However, t is limited in its domain. So the values that t can take are going to affect the values for c that x and y can be. So if we look at the end limits, they're usually the ones that tell us what x and y can be. Not always, but they're quite a useful start. So when x is 0, sorry, when t is equal to 0, we're going to have that x is equal to 3 plus nothing, so just 3. But we've already got that point there. If we look at when t is equal to 2 pi, that's going to be 0 as well because of the sine graph. So we've checked this value, that's 0. We've checked this value as well, that's given us 0. But that's not really helped us, because when we substitute it in here, we're just going to get 3 for both times. We need to look at these points here, or more easily, more usefully, think about the values that sine t are going to be, the biggest and smallest values of sine t. The biggest value that sine t can have is 1. So when sine t is equal to 1, x is going to be equal to 5. So if I mark this value here as 5, when x is 5, y is going to be, we can use the Cartesian equation now and say that y is going to be 6 minus 2 squared. So 6 minus 2 squared is going to be 2. The other point is going to be when t is at its minimum, or when sine t, I should say, is at its minimum. And that's when that's equal to minus 1. And 3 plus 2 times minus 1 is going to be 3 minus 2. So that's going to be x equals 1. So that's going to be on the other side here. And I'm guessing it's going to be the same height. When we substitute 1 in to here, we're going to have 1 minus 3 is negative 2 squared, which is still going to be 4. So 6 minus 4 is going to be 2 again. So that coordinate is going to be 1, 2. So actually, the bit of the graph that we have available to us, or that C is actually just that. Part 2 is a very strange question. It says, explain why it only has this section of the graph. And it's about the fact that even if x, I don't think they mean x is any real number. I think they should be writing t there. I'll have a think about that. Anyway, no matter how big or small t is, it's limited. Sine t is limited to 1 and minus 1. So because sine t goes between minus 1 and 1, x won't ever get any bigger than 5, and it won't get any smaller than 1. So that's why it's not going to ever have all of the graph. Because sine t is limited, x will be limited too. Part C, it then says that we've got an equation of a line x plus y equals k. X plus y equals k lines look like this, that have a gradient of negative 1, and their coordinates add up to the same value every time. So they're going to add up to whatever this k value is, depending on where that line can be. Now that line needs to hit our curve in 2 places. So obviously at the moment the line isn't a valid value of k, because it's not hitting the line at all. But we need to find this line so that we can hit the curve in 2 places like that one. And if you think about it, the first time that's going to happen is when it sneaks in at this 5, 2 point here. That's going to be the first time that the line hits the curve twice. So the smallest value of k needs to fit the equation or have the coordinate 5, 2. So if x plus y needs to equal k, and a point on that line is 5, 2, then that tells us that k must be 7, because 5 plus 2 is 7. So the smallest k that we can have is going to be 7. So that's up here. So say like that value is 7, and we've got a 7 down here. Okay. All the rest of the lines, if you think about me picking that line up and shifting it closer this way, all of those values, it's going to hit the graph twice. The last time it's going to hit the graph twice is the time kind of before we get to the tangent to the curve. So if we can find the tangent line, or when the point is a tangent to the curve, that will give us the upper limit for k. Lines are tangents to curves when they only have one solution. So if we say we want y equals 6 minus x minus 3 squared and y plus x equal to k, we want them to have one solution, then we can solve them simultaneously by saying 6 minus x minus 3 squared needs to equal minus x plus k, and say that we need, if I rearrange this, we need the discriminant of this to equal 0. When I get the discriminant to be 0, I'll get the k value that makes it a tangent to the curve. Okay, and that's the first value that's too big. So we can then just write that in limit notation as an inequality. So if we expand these brackets, we're going to get x squared minus 6x plus 9 is equal to minus x plus k. Expand those brackets, get rid of that, bring the minus in, move everything over to the left. That's going to be, what is it going to be? Minus x squared plus 7x minus 3 minus k equals 0. I'm going to times everything by minus 1 because I don't like negative quadratics. Okay, so that line will be a tangent when the discriminant of this is equal to 0. So if we now find b squared minus 4ac and make it equal to 0, we'll be able to find k. So b squared is going to be minus 7 squared minus 4 times a times this, all of this is c, 3 plus k. So 49 minus 4 lots of 3 plus k. That's 49 minus 12 and minus 4k, which is 37 minus 4k, which means that k will be the line will be a tangent if k is equal to 37 over 4. So that is the first value that makes a tangent line, or it's the only value that makes a tangent line, but it's the first value that makes the line only hit the graph once. So 37 over 4 up here is now too big. 7 is okay, but the smallest it can be. 37 over 4 is too big, so k needs to be the set of values. It asks for this in set notation, so k needs to be between 7 and 37 over 4, but it's allowed to be equal to 7. 7 will give you 2 intersection points. 37 over 4 won't give you 2 intersection points. Sorry, that's a terrible curly bracket. It's a little bit better. So that's your answer for the last part.